Okay, so hi everyone. My name is Samyak Shrimali, and my research is titled PlantifyAI, a novel convolutional neural network-based mobile application for efficient crop disease detection and treatment. So, modern practices and technology have given humans the ability to produce enough food to meet the demand of more than 7 billion people. But food security remains a pressing issue as it is threatened by climate change, decline in pollinators, and most importantly, crop diseases. Crop diseases are not only a threat to global food security, but also affect the lives of millions of smallholder who depend on a healthy yield. Around the world, more than 80% of agricultural production is generated by farmers, and over 50% of their yield is lost due to pests and pathogens. This leads to massive in the food supply and a large number of hungry people, specifically the farmers and their households who account for a fraction of hungry people being 50%. Fortunately, these diseases can be limited and cured by identifying them as soon as they appear on a crop. So, current practices for crop disease identification are based upon significant support from agricultural organizations and local plant clinics. But millions around the world do not have access to these resources, especially farmers in developing and underdeveloped countries. More recently, internet-based video chatting diagnosis tools have appeared, but these tools do not consider that more than 40% of the world's population is lacking internet access. Current solutions for crop disease identification are ineffective, at times inaccurate, and not cost effective. The agricultural industry is in dire need of efficiently and accurately diagnose crop diseases while being free, easy to use, and widely accessible. So this research proposes Plantify AI, a free, easy to use, and widely accessible mobile application that and accurately diagnoses 26 diseases of 14 crop species. Furthermore, this application treatment steps, common symptoms, and access to recommended curing products for each disease. So the development application was split into multiple phases. In the first phase, an efficient and accurate deep learning model was designed through the analysis and comparison of 16 different neural networks based on various architectures and image processing filters. The optimal model, first an image dataset was obtained and pre-processed. The dataset was acquired from Plant Village and consisted of 87,860 leaf images referring to 38 plant classes. Four different convolutional neural networks were designed, all based on different architectures: VGG16, ResNet V2, MobileNet V2, and a custom Keras configuration. So these models are considered four of the most accurate, efficient, effective model architectures for computer vision tools and multi-class classification problems. Next, through the usage of the CV2 library, image processing filters were also applied during the training, validation, process to explore efficient and precise feature extraction. The image filters applied were Gaussian blur, Laplace and canny edge detection. So a total of 16 different neural networks were designed, trained, validated, and tested in the process. MobileNet V2, using the canny edge detection filter, had the highest classification accuracy of 90.7% and F1 score of 96.1. So it was chosen as the most optimal CNN model for Plantify's mobile application. In phase two, this neural network model was optimized for a mobile application using the Flow-Light library. This model was converted from an H5 file to a TF-Lite file, which allowed the model to be used on devices and made the model significantly more efficient. This model was then deployed onto a mobile application in Android Studio, and in Android Studio, the user interface for this application was developed. Um, in phase three, each of the 26 crop diseases were thoroughly researched and analyzed. Through online research databases such as ArborJet and Plant Natural, disease symptoms, disease prevention guidelines, and recommended cure were collected and integrated with the application. This application's user interface consists of two main options for diagnosis. The user can either select and upload a crop photo from their camera roll or take a real-time image. After an image has been received by the application runs the classification model and returns the crop disease diagnosis. Depending on the diagnosis, the user is presented with details on the disease's common symptoms, prevention guidelines, and recommended curing products to use to reduce the disease and cure the crop. Additionally, this app is to tag photos with specific disease labels once the diagnosis is given. This allows to already keep track of already tested and identified crops. To validate and test, high-level testing was conducted and data analysis was also conducted. In the initial neural network development stage, neural networks were designed, trained, validated, and tested, each based on a different model architecture and image processing filter. As I said earlier, MobileNet v2 using the canny edge detection filter was chosen as the most optimal model for Plantify since it had the highest classification accuracy of 95.7% and F1 0.1. After Plantify AI's model was integrated with the application and the application was already designed and ready, real-time testing was conducted at 5 local botanical gardens and extremely well in real time. Out of the 50 leaves tested, Plantify AI could diagnose 46 accurately, as verified by the experts present at the gardens. Furthermore, the experts were quite impressed with the performance of Plantify AI, and in their feedback, they suggested that this application could be environmental as well as a success and significantly increase food security all around the world. In conclusion, Plantify AI identification, fully automated, easy, accessible, and efficient. It can significantly help increase food yields all around the world and help the thousands of farmers, gardeners, and environmentalists who suffer from food insecurity. This app can also make our world more sustainable by protecting our environment, encouraging the usage of proper tools in developing and underdeveloped countries. In conclusion, Plantify allows all farmers around the world to produce crops in an ecologically sustainable way while not having to worry about unknown crop diseases. It has the ability to save thousands of lives every year and promote the usage of tools. With minor changes, Plantify AI can also be converted for usage in many purposes to a web application for um, easy access to concurrent multi-image diagnosis, integrated with a drone for real-time automated surveillance of farms. The possibilities are endless. Thank you.
One question.
Yeah, thank you, Samyak. And we have time for one question, and we have one question for the audience.
I have a quick non-scientific question, but how did you get involved in this as a high school student? And what are your future college and career goals?
Are you looking
Yeah,
everyone?
yeah. So as a high school student, I've been doing research at one of my local universities, Portland State University. And in there, I learned the basic deep learning techniques, machine learning techniques, and I thought of integrating those techniques I learned to a real life problem and trying to solve it. So my future goals are either to get involved with biomedical engineering or become a data scientist, research in college and additional research after that.